Okay, example 3, we're talking about train A, which goes back and forth on an east-west section of railroad track. Its velocity is given in this table. So you guys saw this table in a previous lecture, and now we're doing another part of that released FRQ. Okay, so it says at time t equals to 2, train A's position is 300 meters east of the origin station. We are going to have to use that information at some point, so keep that in mind. That's why I highlighted it. And the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from origin station at time t equals to 12. So let's go ahead and do that first. So usually the way that we denote position is with the variable s. So I'm going to call it s sub a of t. And if I want to figure out what my position is, the first thing I have to say is where am I initially? So at t equals to 2, it tells me that I am 300 meters east of origin station. And so that is my initial position, 300. Then I have to say, okay, well, where have I gone? Well, I have gone from t equals to 2 up to t, because I don't know what t is, of v sub a of t dt. Okay, so that is my position of train A at any time t. It then says to use a trapezoidal sum with 3 sub-intervals to find the position at time t equals to 12. Sorry about the announcement here. Good old Miss Henry telling us to clock in. Yes, I already clocked in and we're ready to go here.
If you see somebody coming in late, please remind them to clock in, because I will not be able to go by and correct that. Mr. Morris, I need you in the front office, or if you'll call me and tell me where you are. Thank you.
Okay, so sorry about that. Hopefully that doesn't happen again as I try to get these videos done for your summer assignment. So use a trapezoidal sum to determine the position at time 12. So let's use the marker here. S sub a of 12. Okay, what I'm going to do is just plug in 12 for t into my formula here. So this is going to be the integral from 2 to 12 of v sub a of t dt. And so what they're wanting us to do is to use a trapezoidal sum in order to determine the approximation for this integral right here. Okay, so here's how we're going to do a trapezoidal sum. If you remember the area of a trapezoid, the area of a trapezoid is 1/2 multiplied by the bases added together multiplied by the height. Okay, well, the height in this case is just going to be the width of the subinterval, so you could call that delta t if you wanted to, the change in the time. Okay, so that's really what the h is going to represent. The b1 and the b2 are just going to represent the y values. So the y values, of course, are in this column. And so what I'm going to basically do is be adding those together, dividing by 2, and then multiplying by the width of the subinterval. Okay, so what we do when we do trapezoidal sums is we basically just put the 1/2 out at the front, because I know I'm going to be using that for every term, because that comes from the formula back up here for area of a trapezoid right there. Okay, so I factor out the 1/2. I then go to the first subinterval. I have 0 and 100 as my y value. Since I'm doing a trapezoidal sum, I'm going to add those together, which is going to give me 100, and then multiply by the width of the subinterval, which is 2. Plus, go to the next subinterval. I'm going to add those y values together. 100 plus 40 is 140, multiplied by delta t, and delta t in this case is going to be 3. I'm going to come down here since I'm kind of out of room. Plus, I'm going to add 40 and negative 120. That's going to give me negative 80. And then multiply by the width of the subinterval, which is going to be 3. Plus, add the y values in this subinterval, which is going to give me negative 270, multiplied by delta t, which is 4. And that is going to give me my position at time t equals to 12 using a trapezoidal sum. So if you put the calculator to that, you're going to get negative 150 meters. And so basically what that means is that train A is now to the west of origin station at time t equals to 12. Okay, example 4, hot water is dripping through a coffee maker. This function c of t represents the amount of coffee in the cup at time t. Okay, so it says to use a midpoint Riemann sum. So we're now going to illustrate a midpoint Riemann sum. Well, if you think about the word midpoint, there has to be something in the middle because we have to take the point that's in the middle. So when I draw my subintervals here, notice that it says it wants 3 of them. The subintervals need to have something in the middle. So I start at 0, I work over until I have something in the middle, which means I would stop at 8.8. Then I start back at 8.8, make sure that something gets caught in the middle there, which means I stop at 12.8. Then from 12.8 to 14.5 so that I can catch something in the middle. So what we're going to be using are these values right here that are in the middle of these subintervals. Okay, so this 1 over 6, we'll talk about what that 1 over 6 is here in a minute. Integral from 0 to 6 of c of t dt is approximately, I'm going to go ahead and put the 1 over 6 there. Okay, and then for the first subinterval, we're going to use the midpoint, which is 5.3, multiplied by the width of the subinterval. Well, the width of that subinterval is 2. Plus, go to the next subinterval. That would be from 2 to 4. We're going to, again, use the one that I highlighted, the one that's in the middle, 11.2. And then multiply by the width of the subinterval, which is, again, 2, since it goes from 2 to 4. And then plus, the last subinterval is from 4 to 6. We're going to use that number that's in the middle for the y value, so 13.8 multiplied by 2. And if you put that to the calculator, you're going to get 10.1. And now what it wants us to do is to use correct units and explain the meaning of this integral in the context of the problem. So this 1 over 6 that's in the front turns this into what's called an average value problem. And so what I want you to always remember is that whenever you see that fraction in front of an integral, that's talking about average value. So this is the average value, and it's the average value of the function that you are integrating. So again, we're integrating c of t, which if you look back up here, is the amount of coffee in the cup. And so this is the average value of amount of coffee in the cup. And let's see what unit that's going to be in. That's going to be in ounces from t equals 0 to t equals 6, and we're talking about minutes as far as time goes. Okay, so there's the midpoint sum. We just did the trapezoidal sum and the problem up there, so let me know if you guys have any questions on that.